Look around you for a moment. You can move forward, step sideways, or jump upward into the air. Every motion you make unfolds inside three directions of space and one relentless flow of time. But here's the strange part. No one truly knows why the universe has these dimensions at all. The stars above us, the planets in our solar system, and even the atoms in your body all exist within this invisible framework. It feels so natural that we rarely question it. Yet physicists have discovered clues suggesting that reality might contain far more dimensions than the ones we can see. Hidden directions woven into the fabric of space itself. Imagine a universe where entirely new directions exist beyond up, down, left, and right. Dimensions so small they remain folded within reality, or perhaps vast realms just beyond human perception. If those dimensions exist, they could reshape our understanding of gravity, matter, and the origin of the cosmos. They might even reveal that the universe is far stranger than we ever imagined. So the real question becomes impossible to ignore. Why does the universe have the dimensions we experience? Were they chosen during the birth of the cosmos, or are they only a tiny piece of a much larger multidimensional reality? In this journey, we're going to explore one of the deepest mysteries in physics. From the motion of planets, to the strange behavior of quantum particles, to theories that suggest entire hidden dimensions may surround us right now. By the end, you may look at the universe and reality itself in a completely different way. Look up at the night sky for a moment. Planets drift, stars shimmer, and galaxies swirl across unimaginable distances. Yet everything we observe shares something quietly fundamental. All of it exists within a structure we rarely stop to question. Humans move through space almost without thinking about it. A step forward, a glance upward, a reach to the side. Three directions seem natural, almost obvious, like the air we breathe. But the universe didn't have to work this way. Imagine a tiny insect crawling across a sheet of paper. From its perspective, there are only two directions to move, forward or sideways. Nothing above, nothing below. Now suddenly imagine that insect discovering a third direction. Our universe appears to give us exactly three directions to explore. Up and down, left and right, forward and backward. Everything from spinning planets to drifting galaxies moves within this invisible grid. And alongside these three directions flows something stranger. Time. Time moves relentlessly forward, like a cosmic river carrying everything with it. Together, space and time form the stage where every cosmic event unfolds. But here's the unsettling thought that keeps physicists awake at night. What if this familiar stage hides more dimensions just beyond our perception? And if that's true, why do we experience exactly these dimensions and not others? Why does reality appear to be built this way at all? To begin answering that, we first need to look at how dimensional structure reveals itself in the universe. Every moment of our lives quietly reveals the structure of the universe. A bird lifts into the air, a leaf drifts downward, a car moves forward along the road. Without realizing it, we're constantly watching objects move through space, and that motion always unfolds in three directions. Think about tossing a ball into the air. It rises upward, travels forward, and drifts slightly to one side. Its path traces a curve through space like an invisible ribbon. That simple arc already uses all three dimensions at once. Astronomers see the same thing on a far grander scale. Planets orbit their stars while moons circle their planets. Comets dive through the solar system in long looping paths. Every one of these motions unfolds in the same three-dimensional arena. But there's another ingredient guiding every movement we observe. While objects roam freely through space, time moves only one way. A planet cannot orbit yesterday, and a star cannot shine tomorrow before today arrives. Time flows forward like a one-way current through the cosmos. Together, space and time form a framework that governs everything. From falling apples to spiraling galaxies, the rules remain the same. The universe behaves as if it were built on this four-part structure. But the deeper we look into nature, the more mysterious that structure becomes. Because when scientists zoom in to the tiniest scales of reality, something unexpected begins to appear. And it hints that the universe may be hiding far more dimensions than the ones we see. Now the journey shrinks dramatically, diving deep beneath the world we can see. Atoms, molecules, and tiny particles form the hidden machinery of reality. At this microscopic level, nature behaves in ways that feel almost magical. Yet even here, everything still seems to live inside the same three dimensions of space. Inside every atom, electrons swirl around the nucleus in complex patterns. Not like little planets exactly, but more like fuzzy clouds of probability. Still, those clouds stretch outward in every direction around the nucleus. Up, down, left, right, forward, backward, the same familiar dimensions. Quantum physics governs this tiny realm, and its rules can feel strange. Particles can act like waves, appearing in several places at once. They can tunnel through barriers, as if slipping through invisible doors. But even these bizarre behaviors unfold within the same spatial framework. Yet some of the boldest ideas in modern physics suggest something astonishing. The universe may contain more dimensions than the three we experience. These extra directions could be curled up so tightly that they remain hidden, like microscopic tunnels woven into the fabric of space itself. Imagine an ant walking along a thin wire. From far away, the wire looks like a simple one-dimensional line. But up close, the ant can also walk around the wire's circular surface. A hidden dimension was there all along, just too small to notice. Some physicists believe space itself may work the same way. Beyond the three dimensions we see, others may exist at incredibly tiny scales. If that's true, the universe may be far richer and stranger than it appears. But before exploring those hidden possibilities, we can first look at how dimensions shape something closer to home, entire planetary systems. Now the journey expands again, leaving the microscopic world behind. Out here, entire planets drift through vast stretches of space. The same three dimensions that guide tiny particles also shape the motion of worlds, and nowhere is that more visible than inside a planetary system. Picture the solar system from afar. The sun burns at the center, while planets trace graceful paths around it. Each world moves through space like a dancer circling a spotlight. Those motions unfold within the three-dimensional stage of space. Gravity is the invisible choreographer behind this cosmic dance. It pulls planets toward the sun while their motion carries them forward. The result is a stable orbit, much like a spinning top maintaining its balance. Without three dimensions, this elegant balance might not exist at all. Moons follow similar paths around their planets. Spacecraft launched from Earth must navigate these layered gravitational dances. Engineers calculate trajectories that weave through space like threading a needle. Every maneuver depends on understanding how objects move in three directions. Imagine trying to guide a spacecraft using only two dimensions. Planets would constantly collide or drift unpredictably. Stable orbits might be impossible, and the solar system could look wildly different. The geometry of space quietly allows these cosmic patterns to exist. Because the structure of space determines how gravity shapes motion, and the better scientists understand those dimensions, the more precisely they can explore the cosmos. In fact, every mission that leaves Earth depends on this knowledge, which leads us to how scientists use dimensions to navigate the vastness of space itself. Every time a spacecraft leaves Earth, it begins a journey through invisible coordinates. To navigate the vastness of space, scientists must know exactly where the spacecraft is, not just forward or backward, but also above, below, and sideways in the cosmic ocean. Space exploration depends entirely on understanding these dimensions. Mission control tracks, spacecraft using precise mathematical maps of space. Antennas on Earth send signals that bounce across millions of kilometers. By measuring how long those signals take to return, engineers pinpoint location. It's like cosmic echolocation, guiding machines through the darkness. Imagine throwing a paper airplane across a room. If the room had no height or depth, steering would be nearly impossible. But in three dimensions, the plane can glide, rise, dip, and curve. Spacecraft follow the same principle, only across the entire solar system. When probes travel to Mars or Jupiter, their paths must be incredibly exact. A tiny error in direction could send them drifting millions of kilometers off course. So scientists calculate trajectories through three-dimensional space and time. Every movement becomes a carefully planned cosmic arc. Satellites orbiting Earth rely on the same understanding. GPS systems track their positions to guide airplanes, ships, and smartphones. All of it depends on mapping motion across three spatial dimensions. But the deeper physics behind these coordinates reveals something even more profound. Because according to modern physics, space alone isn't the full picture. Space and time are actually woven together into something larger, a four-dimensional structure that bends, stretches, and shapes gravity itself. And that discovery changed how humanity understands the universe forever. At the beginning of the 20th century, physics took a dramatic turn. A young scientist named Albert Einstein proposed something radical about the nature of reality. Space and time, he suggested, were not separate ingredients of the universe. Instead, they formed a single woven structure called space-time. Imagine stretching a giant rubber sheet across a frame. If you place a heavy bowling ball in the center, the sheet bends downward. Now roll a marble across that surface, and it curves toward the bowling ball. This simple image captures the heart of gravity. In Einstein's view, planets are not pulled by invisible forces alone. Instead, massive objects like stars bend the fabric of space-time around them. Planets simply follow the curves created by that distortion. They move along the natural paths shaped by the geometry of space and time. This idea explains why planets orbit the sun so predictably. The sun creates a deep curvature in space-time, like a whirlpool in a river. Earth moves through that curved region, tracing a stable path year after year. Gravity, in this sense, becomes the shape of the universe itself. Suddenly, dimensions become far more than simple directions. They form the very architecture of reality. Space and time together create a four-dimensional stage where everything unfolds. But long before Einstein described this cosmic fabric, those dimensions were already shaping something remarkable, the birth of entire planetary systems. Because when stars and planets first formed, they emerged inside this dimensional structure, and the geometry of space quietly guided the creation of our own solar system. Long before Earth had oceans, mountains, or life, our solar system began as a drifting cloud of gas and dust. This enormous cloud floated through space, stretching across billions of kilometers. Inside it, tiny particles slowly collided, clumped together, and pulled on each other through gravity. All of this unfolded within the vast three-dimensional arena of space. As gravity pulled the cloud inward, something interesting began to happen. The entire cloud started spinning faster and faster, like a figure skater pulling in their arms. With each moment, the spinning motion squeezed the material into a wide, flattened disk. The geometry of space guided this transformation. At the center of this spinning disk, matter piled up and grew incredibly dense. Temperatures soared until nuclear fusion ignited, giving birth to the sun. Meanwhile, countless smaller clumps of dust and rock continued circling within the disk. Over millions of years, those clumps grew into planets. The three dimensions of space allowed these worlds to settle into stable paths. Instead of crashing endlessly into one another, they spread out across orbital lanes, like cars moving along invisible highways around the sun. Gravity and geometry worked together to keep the system organized. Moons formed around planets in the same way, gathering from smaller swirling disks. Asteroids and comets filled the leftover gaps like cosmic debris from construction. Slowly, the chaotic cloud transformed into the orderly solar system we know today, a cosmic structure shaped quietly by the dimensions of space. And that structure would eventually create the conditions for something extraordinary. On one small planet orbiting an ordinary star, matter began organizing itself into life. But the very possibility of such complexity depended on the way dimensions shaped the universe. Because the structure of space influences how matter behaves everywhere, including here on Earth. On Earth, the dimensions of space quietly shape every part of daily life. Gravity pulls rain toward the ground while mountains rise upward into the sky. Rivers carve paths through landscapes, and winds swirl through the atmosphere. All of these movements unfold within the same three-dimensional stage. Think about something as simple as walking across a room. You move forward, step sideways, or climb upward on a staircase. Your body constantly adjusts balance using all three directions at once. Even the way we build houses depends on this spatial framework. The structure of space also determines how forces behave. Gravity spreads outward in every direction, pulling objects toward Earth's center. Magnetic fields wrap invisibly around the planet like protective shields. These patterns exist because space allows forces to expand in three dimensions. Matter itself forms stable structures because of this geometry. Atoms bond together to create molecules, crystals, and living cells. Proteins fold into intricate shapes, like tiny machines inside our bodies. Life depends on these complex structures forming reliably. Imagine a universe with only two spatial dimensions. Organisms might be flat like drawings on paper. Circulation systems, organs, and layered structures could become impossible. Complex life as we know it might never arise. The dimensional structure of space quietly makes life possible. It allows ecosystems to grow, planets to form, and atmospheres to circulate. But Earth is only one small corner of this vast dimensional stage. Far beyond our planet, entire galaxies move through this same cosmic framework. Now the scale expands far beyond planets and solar systems. Across the universe, billions of galaxies drift through immense cosmic distances. Each one is a vast island of stars, gas, and dark matter moving through space. And all of them exist within the same three-dimensional cosmic arena. Take a closer look at a spiral galaxy like the Milky Way. Hundreds of billions of stars orbit its center in enormous sweeping patterns. From above, the galaxy resembles a glowing cosmic hurricane. Stars swirl along spiral arms like sparks caught in a whirlpool. Gravity guides this immense rotation across tens of thousands of light years. Stars closer to the center circle faster, while outer regions move more slowly. The entire galaxy becomes a rotating system balanced by gravitational forces. Its motion unfolds across the three dimensions of space, but galaxies rarely remain isolated forever. Over cosmic time, gravity pulls them toward one another. They drift closer, interact, and sometimes collide in spectacular mergers. Stars weave through space like dancers in a slow-motion cosmic ballet. Even on the largest scales, this motion follows the geometry of space-time. Clusters of galaxies gather into enormous cosmic structures. Filaments of matter stretch across the universe like glowing threads. The universe itself appears to have a vast three-dimensional architecture. Yet this structure may trace back to a much deeper origin. To understand why the universe has these dimensions at all, scientists must look back, far beyond galaxies and stars, toward the earliest moments of existence itself. Back to the beginning, when the universe first burst into being. To understand why the universe has the dimensions it does, scientists look back to the moment everything began. Nearly 14 billion years ago, the universe erupted into existence during the event known as the Big Bang. In that first instant, space itself expanded rapidly, carrying matter and energy outward. The structure of reality, including its dimensions, may have been defined during those earliest moments. At the beginning, the universe was unimaginably hot and dense. Particles collided in a blazing sea of energy, and the laws of physics behaved differently. Some theories suggest that space may not have started with only three dimensions. Instead, many more directions might have existed in the newborn cosmos. According to ideas like string theory, the universe could contain extra spatial dimensions hidden from view. These additional dimensions might be curled up extremely tightly, so small that even the most powerful particle accelerators cannot detect them. They would exist everywhere, yet remain invisible to our senses. Imagine a garden hose lying across the ground. From far away, it appears to be a simple one-dimensional line. But up close, an ant walking on the hose can circle around it as well. A hidden direction was always there, just too small to notice. Some physicists believe space itself may contain similar hidden directions. Three large dimensions stretch across the universe we observe. Others could be tightly wrapped within the fabric of reality itself. If so, the universe may be far richer than the stage we currently perceive. And if these dimensions truly emerged during the birth of the universe, then the structure of reality may hold clues about existence itself. Because understanding dimensions is not just about physics. It touches something deeper about how we perceive the universe and our place within it. When we step back and look at the universe as a whole, something remarkable becomes clear. Every star, every planet, every galaxy exists within the same dimensional framework. These dimensions form the stage on which the entire cosmic story unfolds. Without them, the universe would be something completely different. Three directions of space allow matter to move, collide, and organize. Time carries events forward like an endless river. Together, they create the conditions for stars to ignite and planets to form. Even the emergence of life depends on this quiet structure. Yet the deeper science goes, the more mysterious those dimensions become. Theories suggest that hidden directions may lie folded into the fabric of reality. Entire layers of the universe might exist beyond what human senses can perceive. Reality may be far larger than the world we experience. Humanity stands at a fascinating moment in this exploration. Telescopes scan the depths of space while particle accelerators probe the smallest scales. Scientists search for clues that could reveal the universe's hidden architecture. Each discovery peels back another layer of the cosmic mystery. Perhaps one day we will understand why reality chose these dimensions. Or maybe we will discover that our universe is only one possibility among many. For now, the question remains open, echoing across the cosmos. Why does the universe have dimensions at all? And that question reminds us of something profound. The universe is not only vast, it is deeply mysterious. Every new discovery expands our understanding of existence, and the journey to uncover the structure of reality has only just begun.